Okay, now we're going to talk about circles. We've talked about some other 2D shapes, but now we're going to talk a little bit about circles. Circles are a little different than other shapes. I have over there on the lower right a crop circle, and that's one particular kind of circle. That's an interesting phenomenon. And we're going to talk a little bit about why you need these things. People often ask me, well, Mr. Murdoch, I don't know. I'm never going to use any of this, okay? Now, back in ancient Egypt, when they were trying to figure out a circle with a crop or something of that nature, this is before they figured out some of the geometry, they would make the circle starting from the center using a peg and a string. And you'd wind up going back and forth to figure out exactly where the circle would go, because you'd have to walk around from the peg. Now that's very time-consuming and tedious. You could be walking around a large area. So it was actually a pretty big improvement to agriculture and certain other things when people came up with the idea of geometry. And the Egyptians were actually pioneers in a lot of geometry. So when we look at something like the crop circle, we can think, okay, there are some actual uses for things like the circumference, the area, the perimeter. The circumference and perimeter are the same thing on a circle, and various other things regarding circles. Trying to figure these things out by hand is often very tricky. So the geometry enables us to do it in a really much easier way. Okay, so let's talk a little bit about the diameter that I talked about. Diameter is across. If you cut a circle in half, the length from one end to the other, that would be the diameter. It's 2 times the radius. The radius, let's go back to when I was talking about putting a peg in the middle and stretching a string out and walking around. If you put a peg in the middle of the circle and went to the exterior, that is the radius. Not cutting across the whole circle, just half of it. The circumference is the same as the perimeter, and that's equal to 2 pi r, or pi d, which is the diameter. Pi is a constant that's approximately 3.14. Use your calculator for pi. Don't use the value of 3.14 because it's a very long irrational number, so just use the calculator's pi. Area is pi r squared, so pi times the radius squared. So let's look some more at a circle. Okay? Circumference is the perimeter. It's around the circle. You see the C, around, okay? The diameter. See how it crisscrosses across. Radius. You see the radius. It's half the diameter. You see? See the R. Okay? And if you notice the diameter, you can cut the circle in half at any point. It's equidistant. Okay? Same thing with the radius. The radius is from the center of a circle to any point you draw it on the exterior of the circle is going to be the same. So the radius of a circle is very important. Okay, so let's figure what's the area of this circle, the circumference and the diameter to the nearest hundredth. The radius is 5 units. Okay, I'll give you a moment to solve that on your own. Remember, you can press the space bar at any time to pause the video. I'll give you one moment to do that right now. Okay, we're back. All right, now pi is approximately 3.14. Like I said, use a calculator. The diameter, which is 2 times the radius is 5, is 10 units. The area is pi r squared. Okay, so that's equal to, well, what's the radius? 5. 5 squared is 25. 25 times pi, we go 25 times pi. And you use your calculator, it comes out to 78.53981, 78.54 units when we round. Circumference is 2 pi r. That's equal to 2 times pi times r, which is 5. Remember the commutative property. We can reorganize things. So that's going to be 2 times 5, which is 10. 10 pi equals 31.41592 equals 31.42 units when we round. Okay, and I'll see you in the next lesson.